Hey gang, so it's time for the fall midterm review. Okay, so hopefully you have your cards or your paper. I'm not sure which way I got it copied. And then you also have my answer document that I made for y'all. So we're going to kind of use both and we'll kind of see how it goes. So we're going to start off, number one right here. Solve for x and graph the answer. So I'm going to come on my answer sheet and I'm going to put, I'm going to need my glasses on. Let me pause this for 1 second and find my glasses. And that's better. Okay, so 24 minus 4x less than or equal to negative 6 times x minus 7 minus x. All right, so we're just going to straight up work this. We're going to remember that with inequalities, they work the same as equalities. We just have to remember that one simple rule. So 24 minus 4x, I'm just going to leave that the same, less than or equal to. And I'm going to have to hippity-hoppity distributive property and multiply that negative 6 across. So that's negative 6 times x. Negative 6 times negative 7 is going to give me a positive 42 minus x. Now I'm going to look, as I cover this up, I notice there are three terms. Anytime there's two or more than two, I should say, I can put something together. And as I look, I notice that these are both x's. This is missing the 1 in front, so I do have to remember that. Negative 6 and negative 1, I'm going to put those together and get negative 7x plus 42. I'm going to leave 24 minus 4x over here. Now, I need to get my x's over here and my numbers over here. So, I'm going to move this 24 over to the other side and draw my line. So those cancel out. 42 minus 24. I'm going to grab my calculator. Can't talk today. Grab my calculator. Put it in here, 42 minus 24. Oh, hey, kitty cat. I got a visiting kitty cat friend here. We're going to get 18. So this is going to leave me with 18 over here. But I'm going to do another step at the same time. I'm going to add 7x over here while I'm doing this. 7 minus 4. That's going to give me a positive 3x less than or equal to 18. Okay. Now, I'm going to get rid of that 3. So I'm going to get x is less than or equal to 6. I do not have to flip the sign because there was nothing negative in there. I didn't divide by a negative. So here's my answer. So I'm going to go to the 6. I'm going to circle it. I do see the equal sign right here, so that means I'm going to color it in. It's pointing to the left. It's pointing that way. So that means I'm going to shade this direction. And there is my answer. Okay, card number 2. It says to solve for t, and it gives me this equation right here. So let's solve for t. I'm going to highlight that t so I know what I'm solving for. Move everything away from the t. He doesn't want to be with anybody. So I'm going to undo this multiplication right here, and I'm going to divide both sides by 9. So those 9s will cancel, and I'll be left with t minus 7 equals u over 9. Well, over here with the t, I still have the 7, so I'm going to add 7 to both sides. So I'm going to have just the t equals, I've got u over 9, which is some number, I don't know what it is, and I need to add 7 to it. And there is my answer. All right, moving on. Card number 3. All right, so let's see if we can do this one this way. Oh, hold on 1 second. Okay, sorry, I had a quick phone call. Ski rentals at XYZ Rental Company cost $50 to rent plus $25 per day. So I'm going to go ahead and underline that. $50 to rent plus $25 per day. The function can be represented as m of d equals $25 per day plus $50 for the rental. Okay, d is the days and m is the money spent. Ooh, what is the domain of and range? So here we go. We want to know what the domain is, and we want to know what the range is. Now, this is one of those use your common sense. I'm going to the rental place and I'm going to rent skis. Can I rent half of the ski? No, I'm going to have to rent all the skis. So if I think about it like this, if this were my graph, this would be my X and this would be my Y. My X is going to be representing the number of rentals, the number of skis, the ski rentals. What would the Y-axis represent? D is the days, days rented. Wow, number of, I should have read that. Days, we are renting it. And M is the money. So my Y-axis is the money. Okay, so when you go to rent, can you rent for half a day? Well, that's actually a really good question on this one. I'm going to go with I have to rent a whole day. They're not going to let me just rent half a day. So I'm going to move this out of the way now as I look at this. Okay, so my domain. I could rent not at all, right? I could just choose I'm not going to rent them. My domain would be 0. I'm just not even going to rent. Right here, if I rent for 1 day, I could rent for 2 days. I can rent for 3 days. And this is going to continue on until I am done renting. Probably, 5 days I would think would be the most you'd rent, but we'll just say it can go on and on. And we're assuming we cannot rent for half a day. We have to rent it for the whole day. Now let's look at how much will we pay. If I rent for 0 days, because I got the skis, I'm still going to have to pay $50. It's kind of a bogus deal. Okay, what if I rent for 1 day? 1 day. I paid $50 plus $25 for that day, so that's going to be $75. Okay, hold on again. Sorry, I sent my son to get gas and he's having all kinds of issues. Okay, what if I rent for 2 days? Well, if I rent for 2 days, this would be $50 for both days. 25 and 25 would give me 50. Plus the 50 I already had, so that would be 100. 3 days, and you can see it's going up by 25, right? Would be 125. And we're just going to assume it would go on in that pattern. So the thing you have to think about is, can I get half a day's rental? No, we can't get half a day. You have to rent for a whole day. So anyway, when you're doing the domain and range of ones like this, just think practical. Can I rent for half a day? Remember the ones with the text messages? Could I send half a text message? No, you cannot. Okay, so driving in a car heading through North Texas, one can measure the, I see a keyword, the amount of gas used in a table below. I see that word right there. I'm going to think about that for just a second. When I see the word measured, I know that this is a continuous function. And I know if it's continuous that I'm going to have those inequalities. Okay, so I'm going to think about that. Oh, there it is. What is the domain? Okay, well, I know if it's continuous, my domain is going to look something like this. And my range is going to look something like this. So, hours driving. Looks like I'm driving in a car headed through North Texas, and I'm measuring gas. Okay, so it looks like I drove for how long? I drove for about 3 hours. So that means the maximum time I drove was 3. Where does time start? Time starts at 0. It actually equals 0. It starts at time 0, and it ended at 3 hours. Gallons of gas. I used half a tank, 1.5. So it looks like I used 1.5. Where would it start? Well, if I haven't gone anywhere, I start at 0 gallons of gas. I haven't used any. At time 0, I haven't used any gas. But after 3 hours, I've used 1.5 gallons of gas. Okay, so there's my domain and range. Now, the other thing it's asking me, though, is what is my rate of change? What is the change in Y over the change in X? Well, I can see that this is going up by a half, right? Each of these is going up by 0.5, and each of these is going up by 1. So I want to do the change in Y over the change in X. The change in Y is 0.5 over the change in X, which is 1. So wouldn't that just be 0.5 or 1/2? It's going up by 1/2. So I'm going to say the rate of change is 1 over 2 or 0.5. Either one works. All right, let's look at number 5. Number 5, looks like I have a rectangle. No, a triangle, I'm sorry. So I'm going to draw my triangle on here. It says this is 5x, this is 2x plus 5, and this is 1. It says this right triangle has a perimeter of 48 inches. Perimeter is when you walk all the way around it, correct? All right, so if I walk around, let's set this up. 1 plus 5x plus 2x plus 5 equals 48. We're going to set this up and we are going to solve for x. So let's draw our line and let's see what we can put together. Combine like terms. So that's going to give me 7x. I've got a 1 and a 5. That'll give me 6 equals 48. I'm going to move that 6 to the other side. So 7x equals 48 minus 6 will be 42. Divide both sides by 7. X is going to equal 6. Now make sure we solve this right. Find x. Check. I did that. But it says something else. Find the perimeter. Oh, actually we already know the perimeter, don't we? Yeah, it's 48. So 48. We could double check. X is 6. So this is 1. This would be 30 because 5 times 6 would give me 30. 2 times 6 is 12. 12 plus 5 would be 17. 1 plus 17 is 18. And 18 plus 30 is 48. So yeah, just to double check it, make sure it works. Nicely done, nicely done. Number 6. 6 says solve for x if y is 46. So here we go. So y is less than or equal to negative 6 times x minus 18 minus 2. So if it says solve for x when y is 46, what do I need to do next? Hopefully you said change the y to 46. So let's draw our line. Let's see what we get. Let's hippity-hoppity distributive property. So 46 negative 6x, negative 6 times 18. I'm going to grab my calculator real quick. Negative 6 times 18, 108. Two negatives make a positive, so it's 108 minus 2. 3 terms on this side means I can probably put something together. I'm looking and I think the 108 and the 2, I'm going to put those together. So 46 less than or equal to negative 6x plus 106. My x is over here, my number's over here, so I think I'm going to go ahead and solve it, and I'm just going to move this 106 over here. So I'm going to take 106 and take 46 away. This is going to give me 60, negative 60, negative 6x. I'm running out of room. I'm going to divide both sides by what? Negative 6. I need to remember I'm dividing by a negative, so I'm going to have to flip the sign. So here I'm going to have x. I'm going to flip the sign the other way. Negative 60 divided by negative 6 will be a positive 10. I'm getting 6. Positive 10. But I want it to be written the other way. So I'm going to put my x on the left and my 10 on the right. It's pointing to the x. So I want to make sure that it's pointing to the x when I flip it around. All right. Okay. On to the next one. Number 7 says, use the vertical line test to determine whether or not the graph below represents a function. Okay, so the vertical line test. We are going to draw a vertical line test. I only touch the graph once. No matter where I draw it, I only touch once. So, yes, because the line only touches the graph, once. That's how I know it is a function. All right, what is the domain and range of the graph below? Okay, so I'm going to kind of draw it right here. It looks like it starts at 1, 2, 3, 4, 5, 6, 7. So it's right here up at 7. I'm going to say it's at 7. It's got a circle and it's going like this. It wants to know the domain and the range. Okay, first off, I noticed that this is a line. It's continuous. It is a solid line. That means it's going to have inequalities because it has a line. So let's go ahead and put them in. And let's figure out what those boundaries are. Okay, so looking at the x-axis, it starts right here and it goes forever and ever and ever and ever and ever all the way to positive infinity, right? So my left boundary is something, which you're going to write right here. My right boundary is something. Okay, let's look at how tall it is. Oh, it's just right here, isn't it? So this direction goes to negative infinity, but it's not over here. There's no graph over here. It actually starts at, right here at 7, right? Starts at 7, but does it actually equal 7? It goes for forever and ever and ever this direction, which is, right? No, I'm looking at how tall it is. So how do I write the range of that? What is it every single time? Yeah, every single time. It's 7. So I'm going to write this as, I can't really write it like this. I just need to say that every single time y is 7. Now you're looking right here and you see that open hole and you're like, wait a minute, Mrs. Dean, it does not equal 7 right there. You're right, but that's also not part of the function. Because right here, when I put this here and I put, hopefully you put 0 and positive infinity, does it actually equal 0? Oh, there's an open circle. It does not. Does it ever equal infinity? No. So it's going to look something like this. Y equals 7 every single time. If I come over 1, I find the graph up here at 1, 7. If I come over here at 2, I find the graph at 2, 7. So it's going to keep going on. But at 0, 0 up here, these points, no, 0, 7, the graph's not even there. So here's my domain. We're going to start here at 0, and it actually is not even there. It's just bigger than 0, and it goes forever and ever and ever and ever out to infinity. Here, it's just the same number. It's always 7. 7, 7, 7, 7, 7. Y is always 7, 7, 7. So there we go. That one I know. It's a little tricky on that one, but I think you got it. At least I hope you do. All right, let's look at number 9. F of x equals negative x plus 5, and we want to find f of negative 2. Okay, so remember, we have a couple of different ways. One is we can remember f of x is just a fancy way to say y. And we can go to our calculator, and we can go y equals, and we can put in negative x plus 5. Now, we can go to our second table, and we can look. When x is, remember this is the x right here, when x equals negative 2, what does y equal? And there it is. Now, if I asked you to write it as an ordered pair, f of negative 2 equals 7. This is where a lot of you got confused on the test. Remember, ordered pairs are just x comma y. Well, this represents your x. The output is your y. Input negative 2, your output is your y. It's 7. Very important you know how to do that for next year. All right, let's look at number 10. All right, number 10 we have f of x equals negative 2x plus 5. And this time we want to find f of negative 3. I'm going to let you do that and finish that one out. Y equals, you're going to put it in your calculator, negative 2x plus 5. Second table. In case you don't have a calculator and doing this at home. Second table. I'm going to leave that there with you to figure out your answer. Write it as an ordered pair. Remember, this is the x. Your answer is the y. Input the x, the output is the y. All right, number 11. Mom is keeping data on the growth of her children over a period of time from birth. What would be a reasonable domain? Okay, domain. We're keeping track of their growth over a period of time. So that means time is my x. Draw my graph. This is the time, and this is the growth. Starting at birth. So we'll just say that right there is birth. What's that going to look like? Well, most people, it's kind of linear. Looks something like that. What would be a reasonable domain? All real numbers? Like, can it be every single number you can think of? No, because it's not going to be negative. So I know it's not that. Is time greater than 3? No. Here it is, less than 63. I don't even know where they came up with that one. The only one that's logical is right here, starting at 0. So there we go. All right, number 12. Write the equation of a line in point-slope form and given information. Oh, you know what? You guys don't know how to do that yet. That's interesting. I don't remember 2b being on there, but we will go ahead and take a look at it. Write the equation of a line in point-slope form. Okay, point-slope form. Y minus y1 equals m times x minus x1. Okay, there's my point-slope form. So when I give you an equation, this y stays put and this x stays put. They don't move. What you replace are the ones with the little subscript and the m. So here's what I'm going to give you. M equals, on this one, negative 2. The slope is negative 2. And the point it goes through is 4, negative 1. Now, you already kind of know these. You just don't realize you do. This is x, this is y. Nothing new there. You knew that. You already remember we were doing slope y2 minus y1. Well, here's our y1s and our x1. This would be y1, x1. We are just going to plug and chug. So y minus, keep it just like it's written. Let's plug in y1. y1 is negative 1 equals, plug in your m, which is negative 2 times x, remember the dark x stays, minus, and now let's find our x1, which is 4. All right, so there it is. I don't want to leave it like that. I want to simplify it a little bit. Two negatives, hit them together and make a gigantic positive. So this is y plus 1 equals hippity-hoppity distributive property with this negative 2. We're going to do negative 2x. Negative 2 times negative 4 will be positive 8. It's all simplified, so let's move this one over here. Y equals negative 2x plus 7. Yeah, you're like, oh, that's not bad at all. No, it's not. And I'll give you this. I don't remember there being one like that on your test. Maybe there was, and I just missed it. I'm going to go back and look at your test after I finish this review. Oops, sorry, Kit Kat. Sorry. All right, here we go. Number 13. That concludes page 1 of our midterm review. All right, we are finding the 30th term. All right, so here we go. F of 2. That would be my cat scratching. F of n equal, f of 1 equals 2. F of n minus 1 plus 7. Okay, so we want to find the 30th term. Well, that's kind of weird. They give us the recursive rules. So let's write out the first couple of terms. if we can write out the first couple of terms, then we can usually figure out the 30th term. All right. The first term is what? 2. In order to find the next term, you go to the term before it, f of n minus 1. And what do? I add 7. 2 plus 7 is 9. To find this term, I go to the one before it, add 7, 16. To find this one, go to the one before it, add 7. That's term 1, term 2, term 3, term 4. I need to go all the way up to 30. So I think I'm just going to be kind of lazy, and I'm going to get my calculator. I'm going to turn it on. Okay. 2 plus 7, enter. Okay, so 9. Oh, yeah. So I'm at term 2. I'm trying to get out of my light. There we go. Oh, no. This room I'm in has a horrible light. Okay. If I say enter again, oh, plus 7. Now I'm at 16. That's term 3. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Halfway there. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 205 for 30. All right, so the 30th term is 205. All right, number 14, I'm going to give you a sequence. The sequence is 2, 5, 8, 11, 14, on and on and on. Write the recursive rule in slope-intercept form. So in other words, write the rule and simplify it. So we know, remember I'll always give this to you, the first term plus the common difference times n minus 1. Okay, what's the first term? First term is 2. So we're going to find the first term is 2 plus, what's the common difference? What is this doing? It's going up by, hopefully you said 3, times n minus 1. Now, when it says to simplify it, now we're just going to simplify. Hippity-hoppity distributive property. We're going to make it look a little better. All right, so 2 plus 3n minus 3. Let's combine like terms. 2 minus 3. So that's a sub n equals, I'm just going to put 3 in first because I'm going to have a negative 1 on the end. And there we go. All right, number 15. Write the equation of a line in point slope form given. All right, so point slope again. So y minus y1 equals the slope times x minus x1. Remember the first x and the first y stay put, they don't move. So here's what we've got. Our slope given is negative 3, and the point it passes through is negative 4, 12. Even if this ends up not being on our test, we still have to do it. This is the whole next unit, so we'll go ahead and write it. We're just going to plug it in and simplify it. So we're going to say y minus, because we follow this right here. This is my y1, this is my x1. So y1 is 12, so we're going to plug in 12. Equals my slope, which is negative 3, so I just plug it in, times x minus, and we go back to x1, which is negative 4, so negative 4. Two negatives are going to bump together and make a gigantic positive. So y minus 12, we're going to hippity-hoppity. Negative 3x minus 12. I'm going to have you simplify that. Move that 12 to the other side. Y equals negative 3x. Those cancel out. Now, just as a question, That's a very special function. Do you remember what we call ones where there's no b on the end? Oh, you're already going, I remember it, direct variation. That is a special one because it would go through, if I were to graph it, it would go right through the origin. Right? Actually, this one is a negative, so it would go down like that. But it would go through the origin. Goes to the origin, it's a direct variation. All right, number 16. Write an equation to represent the table below. You know what, guys? I'm going to pause it. I just don't think these are on our midterm. Hold on. Okay, that would be negative. So we are going to mark off 16. We are not going to do that one. In the equation 17, we are doing this one. Y varies directly with x. X equals 4 when y equals 16. What is the value of x? X equals what when y equals 12? Okay, these are the situation it gives me. Now remember, direct variation means it's proportional. So I can do one of two things. One is I could just write the equation y equals mx plus b. But remember, for direct variation, there's no b. So I just need to figure out the slope. Well, slope is the change in y over the change in x. So on this one right here that I know, what is the y value over the x value? It would be 4, right? So that means this m right here is 4. Okay, so my equation is y equals 4 times x. And you can check it. If I were to put this x right here, what is 4 times 4? 16. Okay. Well, we want to know what is the x if y is 12. So if I take that 12 and I put it here for y equals 4 times x, what does x equal? 4 times what is 12? 3. There's my missing number. I think that's almost as easy to do as cross multiplying and making it proportional. Is just remember that you can just set up an equation and find it. It's a little bit easier. Go back and watch that if you need to. Determine the slope of a line that's represented by this table. Okay, I'm going to let you do that one. I'm going to remind you. You just want to do the change in y over the change in x. What's the change in y? What's this doing? It's going up by the same thing every time. What's it doing here? It's going up by 1, up by 1, up by 2, up by 2. Maybe I should work that one with you because you might be looking at it going, what? This is going up by 4 every time, right? This one's going up by 1, up by 1, up by 2, up by 2. I have to check every single one. Determine the slope of a line represented by the table below. Well, I think this is kind of a trick question because what we're going to do is we're going to change this. Let's change this to 7, and I may have already done that, and this to 8. That way these are all going up by 1, and you can do it. So it's going up by 4 over 1, so my slope is 4. The other way it was going, it was not going to be linear. How would I have known that? I could have graphed it, but also when I set it up, I'd have 4 over 1, 4 over 1, 4 over 2, and 4 over 2. It has to be the same rate of change each time in order to be linear. All right, let's look at 19. I'm going to make a note on there that I need to change that to 7 and change that to 8. Okay, an airplane lands, or is 25,000 feet above the ground, begins descending on a landing strip. The table below represents the coordinates of his descents. What is the plane's rate of change? All right, rate of change. Let's do our ordered pairs. You've got this is your x and this is your y. So I need to figure out the rate of change. What's this doing? It's going up by, 4. So my change in y over the change in x. Well, the change in x is 4. I can see that one pretty quick. What's this doing? It's going down. How much? Yeah, it's going down by 500 feet each time, right? So that's going to be going down by 500. And you have to think about it. The plane's landing, so of course it's going to be going down. So what is 500 divided by 4? Figure that out and your answer will be negative, and that will be your rate of change. All right, card 20. X and Y intercepts of the following equation. All right, let's just solve it for y and graph it and see if we can figure it out. Move the x, divide the y. I'm going to write it right here. Move x, divide y. So I'm going to move 5x, move 5x. Negative 6y equals, I usually put the x first and then put the number. Divide the y, divide everything, every single one by negative 6. So y equals positive 5 over 6, because negative over negative is a positive. I still have the x. That's going to give me negative 5. All right, so here's my equation. So I want to know what the x-intercept is and what the y-intercept is. I'm going to look. Hopefully I can see them. Y equals, clear it out. Alpha y equals, and I'm going to do 5 over 6 x and then minus 5. I'm going to hit graph. I'm visual. I want to be able to see it. Sweet, I can see that one and that one. So x-intercept is 1, 2, 3, 4, 5, 6. And the y-intercept is right here, negative 5. Here's my intercepts. 21, what would be the zeros of the line? All right, zeros. Heroes stand tall. Zeros lay down. If you're laying down, you would be on the x-axis. Where are my zeros? Right there. 1, 2. I believe it is at x equals 2. All right, 22. Given 2x minus 4y equals negative 8, what is the slope and the intercept of this equation? In order to see the slope, I'm going to have it in y equals mx plus b form. Take a minute, move the x, divide the y, look for your slope, and look for your y-intercept. Pause your video here if you need to. All right, moving on. The next one, I just need to solve for x. Hippity hoppity, I'll get you started and I'm going to let you finish it. 2x minus 8 equals. When you get to this side, you may be like, I forget. What happens? Anytime you're missing a number, put it in. We know it's a 1. Negative 1 times 3x and negative 1 times negative 4. This 2x is in the front. It is not a part of this back here. He's just hanging along. So that's 2x. Negative 1 times 3 is negative 3x. Negative 1 times negative 4 is positive 4. Remember, when you have more than 2 terms on a side, you can probably put something together. What can I put together over here? I can put 2x and negative 3 together and get negative 1x plus 4. And I still have 2x minus 8 over here. This is my x side, this is my number side. Finish it up. Move all the x's over here, move all the numbers over here. Solve it out. All right, pause your video so you can work that. In one basketball season, Lisa made twice the difference of the number of baskets Alyssa made. And you know what? We're not even going to do that one. Just put a big X on 24. Let's not do that one either. All right, there we go, 25. Your midterm doesn't have really hard ones on there like that. I don't think anyway. They're pretty straightforward. Determine the rate of change of the graph. Okay, rate of change. Oh, look at all those decimals. Ouch, yuck, ooh. All right, so I need to find ones like right here. Here's one. Here's one. There's one. You want to find the ones that hit right in the corners. And then we can kind of look. I can do rise over run. So it's a positive slope. How much does it go up? Don't tell me that it goes up 2. It doesn't go up 2. It goes up 40. That's a 40 right there. So change in y over change in x. It rises 40. How much does it run over? 0.4. 0.4. Right? Another way that you could do it, if you're like, oh, I'll never remember that. Find your 2 ordered pairs. 0, 0. This is over 0.4 up 40. You can do it that way too. Either way you want. I'm going to come over here. I'm going to do 40 divided by 0.4. So my slope is 100. Pay attention to your graph. If you're going to do rise over run, make sure you notice how much am I rising? How much am I running? I could look how I rose 100 and ran over 1. 100 over 1 is 100. You could look at it that way too. Which equation which is the equation of the line graph below? Okay, let's just write this one. I can't remember if there's one like this on there either. Sorry, y'all. So if I want to do the equation, if I gave you a situation where I gave you a picture and you had to determine which one it matched, you would just plug it into your calculator and hit graph and see which one it is. So let me do this. Boom. Okay, let's figure out which one it is. So I know that in order to graph it, I need to look at this. I'm going to notice that this y-intercept is at -3. That's the B. -3, -3, okay, so they all are at -3. So I'm not sure which one's right. So I'm going to go to my calculator. I'm going to go to y equals. Let's put it in. -1. Well, let's see. What can you tell me about this graph right here? Is it a positive slope or a negative slope? Read it from the left to the right. It's growing. So this is a positive slope. This is a negative slope. This is a negative slope. Positive. So, okay, so it's one of those. So I've already eliminated a little bit. So let's go here. Let's do alpha y equals 1 over 3x minus 3. Let's graph it. Let's just look. Oh, looky there. Hey, that looks pretty close, doesn't it? I think that's it. I think it's C. I'm just going to check. I'm going to come below it. I'm going to keep that one on there. And I'm going to do 3x minus 3. Let's just see so we can compare them and see what they look like. Oh, yeah. It is definitely not that one. So my answer would be this one. So I'll give you the graphs and you can check them that way. That makes it a little easier. All right, 27. This is the graph of a linear parent function. Okay, linear parent is right there. What would happen if you doubled the slope? So, well, let's just do it. Let's do y equals 2x. Remember, the parent function is y equals x. Double the slope. Let's make it 2x. What would happen to my graph? Do you know? If I go from y equals x to y equals 2x, double the slope. There's the parent. What would you call that? Getting more steep? Getting steeper? What would happen if you double the slope? It would get steeper. Now, I'm going to put it in red right here. It would look something like that. I'll do the next one in blue. What would happen if you made the y-intercept to a positive 2? So if I made the y-intercept right here, wouldn't it look something like this? So I would say what? I would say it would move or shift, whichever way you want to say it, the graph which way? Up. How many units? 2 units. Write the equation of a line if it is reflected across the y-axis, the slope is doubled, and it's translated up 2. Okay, so here we go. Y equals. First off, we're going to reflect it. Reflecting means we're just going to make it negative. Then we're going to double the slope. So let's make the slope 2x. We're going to translate it up 2 units. So I need to say plus 2. There is my new equation. All right, here we go. Last one. What is a situation of a discrete data? What's something that's discrete? I want something that's countable. You come up with something. I'm going to rattle some off real quick. Dogs in a kennel. People in the band. Instruments played in the band. the keys of a keyboard, cars in a parking lot, the markers in a container. You get the idea. Things you could count. The crackers in a box. Give me a situation that is continuous. This is something that I can measure. The time it takes to get to grandma's house. The time it takes to watch a movie. The growth of a child over a period of time. How much water it rains in a rainstorm. How much snows on the mountainside. You get the idea. How much concrete I mix to lay bricks on the sidewalk. Anyway, you get the idea on that. I hope this video helps you guys with your midterm. Thanks for watching.